Starting out, there are 6 numbers I'm going to ask you to remember to start this prime factorization stuff. I got 1, 2, 3, 5, 7, 11. And those are the numbers that we're going to use to simplify these radicals. What do all these numbers have in common? They're prime. So it's prime factorization, so you can use prime numbers. Okay? You could use 13, you could use 17, you can use 23, you can use 19, but these are the ones I want you to remember. Okay? So, starting out, I have the square root of 12. Square root of 12 is one of the radicals that you just kind of need to memorize what it simplifies to. Okay? Square root of 12 and the square root of 8. So what I'm going to do is I'm going to take 12, and what I'm going to end up doing is dividing by one of these numbers up here. Pick a number.
2.
2 or 3. We're going to start with 3 because it's bigger. So 3. How many times does 3 go into 12?
4.
So that's my next number. Pick another one of those top numbers.
2.
2.
And then
2 and then 2. Once you end up with one of your prime numbers at the bottom of this ladder thing, you're done simplifying the radical. Alright, so in order for a number to come out from under the radical, there has to be 2 of them. So think of it like this. This is my one of 2 stories that I tell to remember stuff. You have 12. 12 is in the house. Okay? So if you're going to leave your house and go out on a date, you got to go with somebody, right? You can go by yourself, a little bit weird. But so most of the time you have a date and you go out with them, yeah? So these 2s are going to go out on a date because there's 2 of them. So we circle these 2. The 3 doesn't have anybody to go out with, so 3's got to stay at home. Okay? Yes, the 3rd will, but they're not taking him along this time. So these 2's came out, and these 2 2's turn into 1 2. So I have 2 outside of my radical. The 2's went out on a date. And then the 3 is going to stay at home under the radical. That's your answer. Okay? 2 square roots of 3. If you want to go back and check it, what is 2 squared?
4.
What's 4 times 3?
12.
So you know you did it right. Okay? Alright, so number 2, I have the square root of 75. So again, we're going to pick one of those prime numbers up at the top.
5.
Alright, 5. 5 divided by 75, what do you get?
15.
Okay, 15. Again, one of those 3 numbers at the top. 5. And we're left with 3. 3 is one of the prime numbers that we have up at the top of the page, so we can stop there. These 2 5's are going to come out from under the radical. So I have 5 square roots of 3. So number 4, I have a number outside of the radical. I have a negative 4 out there. And we already simplified 12. We did that on number 1. So what number 4 says is it says negative 4 times the square root of 12. So I take negative 4, and I'm going to multiply it by what the square root of 12 was. And I found that on number 1, 2 root 3. You multiply the stuff that is outside of the radical together. If I had 2 radicals, I would multiply the stuff inside the radicals together. So I get negative 8 square roots of 3. Negative 4 times 2 is where that negative 8 came from. So 5, I have negative 5 square root of 16. What do you square to get 16? 4. Okay. Once you take the square root of 16, 25, 36, 49, 81, anything like that, once you take the square root of those numbers, that radical is then gone. Okay? So, you told me it was 4, so I have negative 5 times 4. So you get negative 20. Okay? Don't say that you have negative 5 square root of 16. When you simplify it, it's not negative 5 square roots of 4. You took the square root of 16. It was 4. So the radical is gone. Okay? Don't do that. That's not right. Alright, so 7, I have 2 square roots of 80k. And I think I know the answer to what I'm gonna ask you. How many k's are there? 1. Good. Technically there's 80, but in this case we're going with 1. Okay? So variables are just like the numbers. How many of the same number does there have to be to go outside of the radical? 2. So how many variables would there need to be? 2. Okay? And it's 2 because we're taking the square root. If it was cube root, we'd take 3. If it was fourth root, we'd take 4. Okay, square root is 2, so there's got to be 2 of the same in order for it to come out of the radical. So we're going to start. I got 80. And what goes into 80? From up at the top. 5. Okay. 80 divided by 5? 16. So what are you going to take out? 4 is not at the top.
Oh, my bad. 2.
2. If you're going to do perfect squares, yeah, 4. So then you get 8, 2, 4, 2, 2. So I have one of the numbers at the bottom of my ladder. That's one of the prime numbers at the top. So these 2's come out, and these 2's come out. When you have more than one number circled, you multiply them together. So I have 1, 2 coming out of here, 1, 2 coming out of here. What's 2? 4. Yeah, 2 times 2, you get 4. So I have 2 times 4 square roots of 5k. Is that k going to stay home, or is that k going to go out?
Stay home.
It's going to stay home because there's only 1. Good. So I do 2 times 4. I get 8. So I get 8 square roots of 5k. So if we multiply numbers together that we take out if there's more than 1, what do you think we're going to do to numbers that stay home if there's more than 1? Multiply. Yeah. So if I had like 240 and I took out a 3 first, I would have 3 times 5. That didn't have anybody to go out with. So I'd multiply 3 times 5 together. 15 would be under your radical. Okay? Questions about that? Pretty easy? Okay.